That was a precursor to India's long and exciting journey into the heart of the unknown. Since then, ISRO has systematically expanded its capabilities by launching projects with specific visions and goals. In 2008, ISRO launched its first planetary exploration with Chandrayaan-1, which lasted 312 days. The mission conducted studies to comprehend the nature of the lunar crust and the evolutionary history of our beloved satellite. It was in 2013 that ISRO turned its attention on Mars. Mangalyaan, India's Mars orbiter mission, completed 4 years in its orbit around the red planet. In fact, the story of the mission became so popular that it inspired a Bollywood film. Within 2 years, ISRO was ready with its next mission, Astrosat. As India's first dedicated multi-wavelength space observatory, it is fully enabled by a single satellite. ISRO's next significant stride into space was Chandrayaan-2, a complex mission to explore various facets of the Moon. The Sun is another fascinating point of interest as it rules the movement of the Earth and other planets. With this in mind, India's upcoming Aditya L1 mission will study the Sun's upper atmosphere. India's space odyssey continues, emboldened by the many firsts for ISRO in the last decade. With Chandrayaan, Gaganyaan and other future missions, the aim is to deepen our understanding of the universe and our place in it. In line with the global agenda, ISRO will lead India into the next decade through expanded research and technology development to build future capabilities in space exploration. In the words of Dr. Vikram Sarabhai, we are convinced that if we are to play a meaningful role nationally and in the community of nations, we must be second to none in the application of advanced technologies to the real problems of man and society. Today, as we continue to launch 1 billion dreams, the sky is no longer the limit for India. The sky has been an object of curiosity and wonder since time immemorial. For thousands of years, astronomers across the globe have studied the movement of celestial objects. It's largely owing to their discoveries that we began to understand our universe. In India as well, astronomy has been a field of study for centuries now. India first ventured into space in the early 60s, when Dr. Vikram Sarabhai laid the blueprint of the Indian space program. It focused on the use of space technology for the benefit of the common man. With the deployment of PSLV, it was now possible for India to launch a payload of reasonable size into space. That was a precursor to India's long and exciting journey into the heart of the unknown. Since then, ISRO has systematically expanded its capabilities by launching projects with specific visions and goals. In 2008, ISRO launched its first planetary exploration with Chandrayaan-1, which lasted 312 days. The mission conducted studies to comprehend the nature of the lunar crust and the evolutionary history of our beloved satellite. It was in 2013 that ISRO turned its attention on Mars. Mangalyaan, India's Mars orbiter mission, completed 4 years in its orbit around the red planet. In fact, the story of the mission became so popular that it inspired a Bollywood film. Within 2 years, ISRO was ready with its next mission, Astrosat. As India's first dedicated multi-wavelength space observatory, it is fully enabled by a single satellite. ISRO's next significant stride into space was Chandrayaan-2, a complex mission to explore various facets of the Moon. The Sun is another fascinating point of interest as it rules the movement of the Earth and other planets. With this in mind, India's upcoming Aditya L1 mission will study the Sun's upper atmosphere. India's space odyssey continues, emboldened by the many firsts for ISRO in the last decade. With Chandrayaan, Gaganyaan and other future missions, the aim is to deepen our understanding of the universe and our place in it. In line with the global agenda, ISRO will lead India into the next decade through expanded research and technology development to build future capabilities in space exploration. In the words of Dr. Vikram Sarabhai, we are convinced that if we are to play a meaningful role nationally and in the community of nations, we must be second to none in the application of advanced technologies to the real problems of man and society. Today, as we continue to launch a billion dreams, the sky is no longer the limit for India. The sky has been an object of curiosity and wonder since time immemorial. For thousands of years, astronomers across the globe have studied the movement of celestial objects. It's largely owing to their discoveries that we began to understand our universe. In India as well, astronomy has been a field of study for centuries now. India first ventured into space in the early 60s, when Dr. Vikram Sarabhai laid the blueprint of the Indian space program. It focused on the use of space technology for the benefit of the common man. With the deployment of PSLV, it was now possible for India to launch a payload of reasonable size into space. That was a precursor to India's
So we welcome one and all present here to the fourth day of plenary session 2 on middle atmosphere, atmospheric coupling, dynamics and climate change. Today we have for this session the session chair Dr. Kishore Kumar K from SPL and Dr. D. Bala Subramaniam from SPL again. The conveners and co-conveners for this session are Dr. Kishore Kumar K, Dr. Tarun Pant, Dr. D. Bala Subramaniam, and Dr. Nirvikar Dashora. Just a few announcements to make. Firstly, tomorrow we are going to have our closing session, closing ceremony. So please use the link which is on the website, which is given uh, to all the attendees. And it's there on your mail and it's also there on the website. So please join us on the closing ceremony using that link and not today's link for plenary session 2. And finally, again, a word of caution to whoever who is presenting. If you find a pop-up during presentation requesting access to your desktop, please ignore it or deny it. From here, I will hand over to the session chair.
Thank you, LOC. A very good afternoon. I welcome all the participants for the day 4, session 1 of PS2. Today we have almost 16 presentation. In first session 8 we have, in second section we have 8. But in second session we have 1 absentee. I think those 7 will have. All exciting presentations are lined up. Most are the concerned with lower atmosphere dynamics. So gradually days are progressing from upper atmosphere to now we are coming to the lower atmosphere. Now I invite Dr. Balasubramaniam to chair this session.
Thank you, Dr. Kishore. It's a warm welcome and good afternoon to all of you. We will be having total 8 presentations today. I welcome all the speakers and the delegates and the attendees. I may request all the speakers if they can keep their presentations intact, maybe about 12 minutes. We can have a good time for discussion and taking some questions. And also I may encourage the people, if they can focus more on the results, it will benefit the forum. So with these remarks, may I please now invite Dr. Samaresh Bhattacharjee from Aries Nainital, who will be giving a talk on Aries Wind Profiler, first Central Himalayan VHF ST radar. over to Samresh. You try to please complete.
Yes, sir. Very good. So let me share my window first. Yeah. So is it visible, sir?
Yes, it's visible in full screen. You please go ahead.
Okay. Thank you, sir. Thank you to all. Thank you for giving me the opportunity to present Aries wind profiler. And very good afternoon with some cold. Here it is, snowfall is going on. So I'm going to present about Aries wind profiler, which is now in operations. I'll present its about the system, its installations, and some results, some observation results which we captured using the system. So before I go to the main content of the presentation, just to give an overview about the observing facility at Aries. Here it is range from trace gas measurement to aerosol to meteorological instruments. So many instruments are there, and one of the instrument is wind profiler radar, that is stratosphere troposphere radar. So, what is wind profiler and why it is at Aries? We all know that wind carries the all signature which is happening in the atmosphere, and it is very important to monitor this wind to understand the atmospheric dynamics. And in this regard, ST radar is a very useful tool, a very excellent tool to monitor the wind, and it gives the wind information with a high temporal resolution almost in all weather conditions. So in Aries, it is wind profiler. Aries is very close to the Himalayan region, and Himalayan region, as we know, that it plays a crucial role in determining the meteorological conditions of the Indian subcontinent. And this region is also dominated by western disturbance. And this Aries wind profiler is first time it has been attempted to design a wind profiler in 200 megahertz band, balancing between 400 megahertz and 53 megahertz, two popular frequency of the wind profiler applications. And entire system is housed in one building and placed on the hilly terrain. So now coming to the different subsystems of the ST radar, as I have already mentioned that it is totally housed in one single building. Top of the building is the active aperture antenna array. Then bottom of that is the transmit receive module, and the ground floor it is placed the signal processing system. That means in one building, when it first time it has been designed, has been attempted that using the limited space on hilly terrain, how a 200 megahertz wind profiler can be made operational. So now one by one, I will come to the all subsystems. So first it comes the active phased array. This phased array is placed on the rooftop. It was a very difficult task to, because at one go to place the entire array, it is arranged in quasi-circular aperture with 588 elements in equilateral triangle grid. It has an advantage that without appearance of getting lobe, it can be tilted to 30 degree from off zenith. And the another inherent advantage is the fast side lobe level is close to 17 dB down from the main lobe without any amplitude tapering. And this antenna is connected with the TRM through this J tube, and the power is coming from the TRM from the bottom of the this floor, and it is connected with the antenna. So this is also innovative design how antenna and TRM are placed. So now coming to the TRM, so there are also 580 TRMs, and these TRMs basically it amplifies the transmit signals and give it to the antenna, and then it receive the reflected signal back from the atmosphere and sent to the signal processing system. So if we see that how the TH6 operates, this TX pulse is coming from the common path, it is going to the amplifier and it is going to the antenna, and in receive time, when the reflected signal back from the atmosphere, it is coming through the LNA and going to the DSP system. So this TX and RX, it happens in entire operation. Now, these realizations of the active phased array, that means already that I have shown that antenna aperture is on the rooftop and the below the TRM, both form this active aperture, and it generates the required radiation pattern. This is the simulated pattern, but the same pattern can be verified using the phase and amplitude measurement of the antenna array. And this using this radiation pattern, whatever the signal is coming from the atmosphere, that is captured through the from range by range and processed by the signal processing system. Now, one important aspect which we can understand using this animation, that is the beam steering technique, because this is a 30-meter aperture phased array. So using the phase shifter, which loads all the phase as per the tilting angle, then it's still the beam to the different directions, and using this system, electronic beam steering technique, at any directions of the atmosphere can be scanned. Now coming to the measurement of the system. So this system is meant for to measure the wind parameters. Wind is a vector quantity. It gives the wind magnitude and directions. So there's a popular technique that is Doppler beam swinging technique. It also applied in this Aries radar. It sends the signal to different direction, north, south, zenith, east, west, and from that reflected signal captured to the from the direction, then it processed to the signal processing system and extract the Doppler from the radial signal. So through these animations, we can understand that how DBS works. So DBS works like that. Antenna is targeting at or looking towards a different direction. It's sending the RF signal, and RF signal is coming from the layer by layer from the atmosphere. Then within the next few microseconds, it is processed by the signal processing system, and then it is plotting the Doppler with respect to the height. So that's how this DBS system of the Astrosat is work. And as you can see, this radar is placed on the hilly terrain, and even the Himalaya is very close by. So there is a effect of this hilly terrain, which also we face during the installations of this array. So I'll come there. So this is the characteristics of the Doppler spectrum, and from this Doppler spectrum, movements are calculated, and Doppler seed spectral width, and using all these parameters, scientific results are being estimated. So these are the all basic signal processing scheme of the wind profiler radar. So now I am coming to some sample profiles. So we captured so many profiles. So some of them are here. That is from clear air spectrum, and one of the spectrum where both clear air and precipitation spectrum, the spectrums are visible. Basically, it is due to the Bragg and Rayleigh scattering. So that is the one advantage of this type of 200 megahertz radar, that both clear air and precipitation signal is visible on a single spectrum. Now coming to the point which we have faced during our installation, probably not faced by the other similar type of system, that is the effect of clutter due to the mountain. So when we radiated the first time, so we saw that there's a huge clutter signal, and it was necessary to minimize the clutter signal, and we understood through different experiments that it is happening because of multiple reflection from the nearby hilly terrain. And because as Astrosat is based on the hilly terrain, and it has a effect, it has a good return of clutter signal from the hill, and it was masking the entire wind profiler signal. So it was necessary to minimize that clutter signal, and for that we did some engineering. We installed a clutter fence around the antenna array. We designed this fence by analyzing the terrain profile around this antenna array with a 4-meter height clutter fence we have installed. And we can see here that after installation of the clutter fence, how much the clutter signal has come down. 1 TRM outside the fence and 1 TRM inside the fence, there is a good difference, and nearly 25 dB shielding efficiency we have achieved with this clutter fence. Now, which is very important, that once wind profile is installed, that wind measurement is compared with the collocated Aries RW, the balloon launch, which we have the facility, and it shows the good agreement, and we are doing the similar experiment year by year, and every time we got a good experiment, a good correlation between balloon measurement and wind profile measurement. This is the one of the sample profile, just to give an idea that how real time the spectrum. We saw the spectrum. This is the one of the event 5th May 2020 during the hailstorm of 5 beams, how the spectrum is varying. Now coming to the some result, which some of them are published, some of them are pipeline. So there's one result which already published, that is the turbulence parameter. It has been measured using the Aries radar, and we got at least one order higher the turbulence parameter than the southern part of the country. And this is the one of the results which where we got a good signal above the 20 kilometer. This radar was designed to achieve a height coverage up to 20 kilometer, but we crossed beyond that, and we can clearly see the tropopause and reversal of the wind direction. So this is another good observation. This is the observations where the precipitation signal and clear air signals are both visible, and this type of observations using the Aries radar can be used for different scientific outcomes like range of size, distributions, and other parameters. So this also we have captured. This is the one of the event dynamics of extreme weather events. Like here, the wind pattern is severely varying with the height. That also we captured, and it is up to 20 or 22 kilometer. There is a good signature. Then it was our a optimistic experiment, like to capture the evolution, means how evolving it is the boundary layer, because with this antenna is having a 1 kilometer far field region. Within the far field region, it generally says the signal quality will not be good, but we captured the boundary layer, means how it is changing in different season, monsoon season and winter season. Now coming to the one important aspect of that is the internal developmental work to maintain this system operational. It is very necessary that in-house developmental work in-house is very necessary, and we have taken up so many developmental work. We developed the software to analyze the antenna pattern. We developed EAGU the antenna. We developed the TRM, and production of all these models will come in near future, which will help in the maintenance of our system. Another important developmental work which we have taken and completed, that is the in-house customized data processing tool. Using the data processing tool, so far we are analyzing all our data. As I have already mentioned, clutter is still there, so we implemented a specially designed clutter filter to remove the clutter and to get the clear air profile for the scientific outcomes. Now coming to my last slide, that Aries radar is in operation, and now it is become part of the country's network of the wind profiler, and that network have taken so many experiments to understand the synoptic phenomena of the country's countrywide meteorological event, and so many operations, so many joint observations are also planned in near future. So thank you very much. More scientific result will be presented by Aditya in subsequent result. And we also acknowledge the support from ACRB DST, as this project was funded and supported by them. Thank you very much.
Thanks a lot, Samresh, for a very crisp presentation, and it is heartening to know that Aries is adding up the facilities which are really an asset to the organization as well as to the India. So I always encourage that such kind of facilities, more researchers from across the world, across the country, from universities make use. It will be really good. He has given a very good flavor. So maybe I can take a couple of questions, if any. Quick, they can post on the chat box or they can raise the hand. I don't see any questions, but I have one minor query. I am very happy to note that, Samresh, that the radar output there, actually we are going to make use for the lower atmospheric studies also. I may feel that the trade wind inversion over the ocean, over the hilly regions, it is not being investigated in detail, and whatever we know is rather limited. So I think that area one, actually, if we can focus, that will be very good. And also, in addition to your other instruments, I think Lee waves and mountain-driven gravity waves kind of things. I am sure that in coming years, we are going to see.
We also capture some gravity event, gravity wave event. Yes.
So I wish you and your colleagues all the very best. Thanks for keeping the time.
A question.
Sorry, my colleague Kishore has a
just
question.
one thing, Subbu, I wish to add here. Should I?
Yeah.
Basically, basically that I think mountain peak, there are the dynamics is mostly driven by that Himalayas, which are very close to the Nainital.
You're right.
So one thing that should be looked into. Another thing, at the very lower altitude, if you see the very low altitude, that amplitude may be very small, the gravity wave amplitude, due to higher densities. So it is little I think tricky and difficult to get that. But mountain wave, of course, like that part of that thing. Okay, just I wanted to add that. Okay.
Yeah, I think Kishore has a question here.
Yeah. Samresh, this is me, Kishore from SPL. Very good to know that your radar is giving very good results. I have a doubt whether this radar, you have shown the double traces during the precipitation, whether when there is only snowfall, whether you get any echoes, snowfall?
Snowfall, yes, we also captured the snowfall echoes, because right now at present snowfall is happening and our radar is also running. So I probably cannot show you, but we are getting a good signature of that.
Okay, that one. And second thing, have you ever tried for getting echoes from ionosphere?
We attempted, but we are going to attempt in next month. It is already planned in our this joint operation. It is already planned, and we are going to do that.
Okay,
We
good. All the
need
best.
to tilt around 45°.
Yeah.
We can tilt that, and we are going to attempt once it is attempted, but we will again attempt that.
Good. Thank you.
Thank you. I think Nirvikar has posed the same question. Nirvikar, I think your question is answered. Because he put the question in the chat box that is this radar being used for ionospheric studies?
Yeah. It can be used.
Has already responded to that.
Yes,
so
yes.
I am very thankful for a very crisp presentation. So we will move on to the next one. I'm having great pleasure in inviting Som Kumar Sharma, my old friend. We always used to meet in NSS, and it is coincidental that this time we are meeting online. So over to Som. I request him to present his paper on the atmospheric investigations during COVID-19 pandemic. Som from PRL.
Okay, thank you very much. Can you hear me all?
Yes, Som, your slides are
thank you very much for the organizers, and special thanks to the session conveners and to Kishore and Subbu. We all are together, though this time online, and that giving me opportunity to speak to you all on this platform. As you all know, and directly and indirectly, suffering from really very, you can say, bad pandemic situation that's created by the COVID-19. So during this COVID-19, there are, you can say, it has taught us to live little differently, and same time it has modulated the atmospheric parameter, which are unprecedented in the mean. In natural process, these type of things are very difficult to get. And I can say, just in as a preamble, every day there is a sunrise and sunset. Okay, but the solar eclipse makes the things entirely different from that. Basically, solar eclipse also just it cuts the flux for only a small duration. But you see, there are so many processes are modulated at the same zenith angle, and that's what it gives us opportunity to investigate various newer processes which it is difficult to study during the normal times. Unprecedented complete lockdown, I think, in the history of India, or even in the global scenario, if you see, it was there. That was unprecedented. It is difficult to put it in the normal situation. So that how it has changed this type of things to atmosphere. So this is based on basically the two papers, one already recently published and one is, I think, that under review. And in that, I would like to just, and these are my colleagues, basically students, and my junior colleagues, Saurita Saha, Dharmen Kamath, and our another colleague from SAC, Prasant Kumar, like that. So they are equally basically part of these studies, which I am going to present in front of you all. So you just outline, if you see that little introduction, what are the atmospheric impacts, and most importantly, I would like to say that what are the changes in the atmospheric boundary layer during COVID-19, and resultant summary, of course. So we scientists, though we are doctor, but we are doctor of the atmosphere. We are not doctor of the, you can say, the medical doctors. So epidemiology is a branch of, you can say, scientific investigation of spread and control of any disease. So if you see epidemiology like that, human to human transmission via respiratory droplets, all these things, you know that within 4 or 5 days, if you have come in the close contact of some infected people, after 4 or 5 days, you may see the symptoms if your immunity is down. And then symptoms may last in this scenario like that, this newer version, when we are protected with the vaccines, 5-7 days, and earlier it was 11 to 14 days. And then the complications you all have seen, faced, and still few are facing. There are from severe to very severe. Okay, that I will not go in that detail. Okay, I am coming directly to objective of this study. If you see, there are different seasons like in Antarctic, mid-latitude, tropics, mid-latitude, Arctic. So I tried to look into in the first phase, in very first phase. You see that there was in Western countries, there was a huge, you can say, number. But in India, somehow, due to complete lockdown and as well as some other atmospheric factors, or you can say our immunity, we were little protected better than others. So then we try to look into the atmospheric scene, the temperature, moisture, particulate matter, nitrogen dioxide, and boundary layer. And in that, the important factor is R0, reproduction number, which is basically measure of that reflects infectiousness of the disease, how fast it is spreading and how it is happening, and then how the COVID-19 transmission for tropical and mid-latitude countries has taken place. On just I will give flavor here. For detail, you can look into the papers. So this is basically just a cartoon. You are showing that how the atmospheric boundary layer got affected. I will talk in at the end, and then you know that the temperature is regulated by outgoing long wave radiation, convective process, and turbulence, and so many things are there. These are known to this community fully, but during COVID situation, how these things got modulated and how they affected basically science, or you can say the parameters of the atmosphere. So that, as I already told, RO is the estimate of the speed at which the disease is capable of spreading in a population. And I would like to just emphasize here just one thing. I'll just take one pointer. Okay, this is laser pointer. Okay, so if you see here just you see when R0 is more than 1 and R0 is less than 1. So the infected population is represented by R01 when there is an increase. Because how much increase is there? Likely to decrease if it is like that R0 is less than 1. That you please just remember, this will be the focus here. When R0 is more, it is spreading very fast. If R0 is less than 1, then it is spreading little slower and the number is reducing, maybe reducing. And now if you see the graphically what we found in our study, sorry, I forgot to update, this already appeared paper in the recently in the last month of December. So if you see here what is plotted like that, COVID-19 incidences, and this is as I told in early stage of the COVID-19 onset in the March, April 2020. So if you see that how the number was increasing little exponentially, and when we try to look into the estimated R0, if you see it was high, okay, and then as the lockdown was there, so then it became down. That's what it stopped the very steep exponential growth. I will say the lockdown was very helpful. Some people say like that lockdown was not helpful, but lockdown was very helpful because it did not allow to multiply the number at exponential growth as it had happened in the Western countries. So the value of R0 increased further after 1st April over India little bit. Okay. And the afterward also R0 was more than 1, indicating that epidemic was not still going on. What had happened? Basically, when the flux of the people started from moving to from one place to another place, then it modulated the R0. I'll not go in that detail. But now I am coming to the atmospheric parameter. If you see the tropical versus mid-latitude scenario, just reproduction number on the y-axis and the temperature and relative humidity just for sake of representation. If you see how they are like that, that R0 is like that temperature wise, how it is confined in the tropical region if you see the mid-latitude region, and same if you see the relative humidity. So that if we basically put into the action, then we found that we were little protected from the atmospheric side also. And then if you see other weather parameters like during lockdown, how they have basically changed over this one. So sample temperature, humidity, aerosol optical draft, PM 2.5, nitrogen dioxide, and so many things like that. So if you see the control year 2019 and the 2020, if you see the blue line here is 19 and red line is 20. So almost you can say that every parameter except the temperature was showing on the lower side, but of course if you put the uncertainties, then it may be almost similar. It was not much change. But if you see the PM 2.5 CO, if you see the dust, if you see the PM10, and if you see the humidity, every parameter was modulated, I will say. Almost every parameter, and that modulation you can say it was observable. It was clearly observable above the significance level, and that was due to the complete lockdown, as I told, the solar eclipse. The complete, you can say the immediate cut of the flux from the sun. So that basically it is not only affected these parameters. If you see the dynamical part, then dynamical part also has been modulated during that period. And then how it came up, what was the hysteresis effect of these parameters. That also several authors or several groups are studying, and that basically it is like that from 19 control year, 20, 21 and 22, and still episodically it is going on, and there are controlled you can say the state restriction, district wise restrictions or containment zones are there, how they are affecting and how that is affecting. So if you see the global Indian scenario, so pre-lockdown and basically during lockdown, you can see that Indo-Gangetic plain here, that if you see the PM 2.5 pre-lockdown, and then if you see that during lockdown, it was like that empty box. Again, I'll say that like empty box type of thing. So if this type of situation in that you can say the highly polluted region, which is where the boundary layer is very shallow during the winter period, in the go to Indo-Gangetic plain, and if this much cut in the you can say anthropogenic activities, so that will have a very you can say observable or you can say meaningful impact on the atmospheric parameter, that we have tried to look into the detail. Then if you see NO2 if you see there is a change, but in Na2 lockdown also you see then few pockets are here, and these pockets when we found like these are the in the Odisha and some part these are power plants, and during the lockdown the power plants were not shut down because there should not be power shortage. So there is a change, but you see that where there was a basically the concentration of power plants were there at that places, still there was a lot of NO2 and other gases of course was there. And then AOD and if you see that pre-lockdown and post-lockdown how these have changed, you see again you see the Indo-Gangetic plain, this is pre-lockdown and this is the lockdown period. You see complete you can say change in that at least in this part of region which is mostly highly polluted. Okay, and the last point I wish to add that the atmospheric boundary layer plays very vital role in basically you can say it is pump type of thing. During night time it is shallow, at day rises that boundary layer becomes up and it goes down. Everybody it is knows, but it has a very high the regional, seasonal and temporal variations, and it is affected by various atmospheric parameter like the surface, the latent heats, and so many fluxes are coming into there. And then of course the solar system or sorry sun is governing that radiations which are outgoing from the earth and incoming. Yes, just I am last slide. So that if you see the atmospheric boundary layer, there is a over Ahmedabad, this is by using LiDAR, you see the winter summer difference. There is a usual winter summer difference, but if you see during the lockdown period, this is we were lucky to have observation almost you can say during lockdown also. So this is control day, okay, 2nd April 2019, and this is you see the lockdown period. So it you can appreciably what is the change. One thing, the peak came early, the height came down, and you look like that. You see this is a full box and this is like empty box. So there are so many other things that can be looked into our paper which is recently I think one published and one is going to come. And with this I am that basically came to the end. Just see the summary, and one line I can summarize. This lockdown or pandemic have gave us lot of suffering, but for atmosphere it has given like that and you can say the a special event type of thing which is basically very very difficult to get that type of event, and gave us an opportunity to look the cleaner when the atmosphere is clean, how the different atmospheric parameters are changing. With this I would like to say we wish to see the COVID-19 free world, and please follow all the precautions, and wish you very happy, healthy and enjoyable life. Thank you very much. Sorry for taking 1 minute extra. Thank you, Subbu. Thank you very much.
Thanks a lot, Somji. It was a very informative talk. I may like to take questions from audience, if any. In the meantime, I have a couple of minor clarifications. First of all, this was very impressive and very interesting talk. But what was slightly worrying me was the estimated R value, what you showed in the second slide. Despite 4th to 5th day, I was worried that it is still not going below 1. Probably that gives a message that we may have to keep living with COVID because it may not completely eliminate. But anyway, that is only for 4 to 5 days. Probably if we expand beyond that, it may come even below 0. And one more question which I would like to just to seek the clarification is the boundary layer height during the summer season from probably 8 o'clock to 10 o'clock shows very rapid growth. which even I have seen in the other stations. But in the case of winter time, it goes steady and peaks at about 14 or 15 hours. So do you have any quick clarification on why that difference
Basically,
happens?
I can that answer for both the things. As you told that R0 is not going below 1, that is very much true. We have analyzed the long series later also, because this what happens in some pockets there are not much testing, and there are people are there, they are spreading, and that when you see that numbers are coming. And another thing what I'll tell, that for boundary layer, I think these fluxes are that place to place, and then what is the heterogeneity on the surfaces. So that may be the one of the reason for this, what you have that told the second point about that steep during that period, that I want to say.
Yeah, overall it is very good presentation, Somji. Thanks for keeping the time. Now we will move on to the next presentation. Next presentation will be by Dr. Siddharth Shankar Das. He will be making his presentation from this terminal only. He is going to talk the diagnosing the stratospheric water vapor to climate change. Over to Siddharth. He will make a presentation from here.
So you have to.
Okay, I'm trying. Yeah, I'm trying to how to open set. It is closed now. I will close my presentation itself. It is closed now. I am putting up my mic.
Yeah.
Okay. Thank you very much to all.
Yeah. Can LOC confirm whether full slide is there?
Yes, we can see your slides in full screen.
Yeah, good afternoon. Now I will be presenting the diagnosing the stratospheric water vapor to the climate change. So if you see, the most of the water vapor is pumped from the lower atmosphere to the stratosphere, because I'm talking about the stratospheric water vapor through the convective processes. And water vapor is one of the most greenhouse gases which play a vital role in the Earth atmospheric budget. So there are a lot of estimation has been done, and if you see, there are the climate feedback of 0.3 watt per meter square per Kelvin due to the increase of the stratospheric water vapor, because 5 to 10%, it is almost like 5 to 10% responsible for the global warming. And any variation in our two annual water vapor distribution has a significant impact on the global system because of that 3.3 watt per meter square. This is very huge. So one of the most important thing is that any increase in the stratospheric water vapor will act to cool the stratosphere but warm the troposphere. So I will just show the comprehensive study, because this is not a one study. There are so many studies we have carried out in the stratospheric water vapor. So I will be presenting a glimpse of the things what we have done at SPL. So as I said in my previous slide, that a component of the radiative forcing of the climate, if you have if you see the stratospheric water vapor from the methane oxidations, that itself is like a 0.03. But if you say the stratospheric water vapor from the convective process plus or other advection, that will be nearly 0.3. So on order more than that of the methane oxidation. So you can see this radiation forcing, the component as water vapor is more important in the radiative forcing. So what are the factors which is controlling the stratospheric water vapor? As I said, the overshooting convection, the slow ascent or advection, tropopause temperature, methane oxidation, which is occurring at the height of the 30 kilometer. But we generally forgot to take the ENSO, effect of the ENSO, that is the warm phase and cold phase, that is La Nina and El Nino. Then QBO, and of course there is short scale, but that still have a impact, which is the diurnal tides. So one of the things that from 1980 onwards, if you can see, there are a lot of satellites which gives the stratospheric water, because that is you cannot measure the in situ measurement except the Frost hydrometer with other measurement continuously. There are the dials are there, but still we have a satellite observation which will cover the globe, and you can see there are a lot of satellites are there which is still covering. And Aura MLS is one of the most important satellite which we have mostly used. Then apart from that, temperature profile from the CHAMP, from the Cosmic 2, this is the GPS RO techniques, different techniques I have written over here. So these things we have used for our study. This is the geospatial distribution of the water vapor, or ozone and water vapor. You can see the left panel is for the water vapor, and you can see the distribution of water vapor. It changes along the season. And this is the right panel is for the ozone, because water vapor in the stratosphere is one of the cleaning mechanism. For the cleaning means in terms of the destruction of the ozone because of the OH formation. So if you see this geophysical distribution of the tropopause, if you see the tropopause in the month of the January and July, this is the actually I have forgot to put the scale. This is the tropopause height, whereas this one, the second panel, this is the tropopause temperature, and you can see the node structure. 3 node structures are there, and we confirmed with these 3 node structures of the tropopause temperature by the Walker circulation. And if you see this panel, there is a December, January, February, and June, July, August. You can see in the December, January, February, there is a lot of water vapor over the southern hemisphere. It pumped to the mid troposphere, but still very, very cold, very, very less. There is a dry part in the stratosphere. So this shows that there is some other mechanism. It is not the availability of the water vapor in the lower atmosphere, but there is some other mechanism which is there, even though there is a Walker circulation is present. But if you see the June, July, August, the water vapor which is present in the lower atmosphere can penetrate to the stratosphere. So this was we have tried to investigate what was the thing, and we have I will show in my next slide, next to this slide, that how the tropopause temperature was controlling there. And now coming to the Asian summer monsoon region, this is the water vapor. This is the water vapor over the globe. When you average the water vapor of the globe, you can see the water vapor enhancement as I shown in my previous slide. But if you see the Asian summer monsoon region, because a lot of water vapor is penetrating to the Asian. Yesterday there are a lot of presentation on the Asian summer monsoon, so most of the water vapor is trapped over here, over here. And if you see the averaging only over the Asian summer monsoon, there is a kink. There will be one secondary peak is observed, and this is actually because of the secondary circulation over here, which is as a Asian summer monsoon anticyclone is sitting over this location, as well as the vertical velocity is very, very high over the Indian monsoon region, which penetrate the water vapor to the stratosphere. And most of the stratosphere is pumped to this. Most of the water vapor is from the lower atmosphere is pumped to the stratosphere, which is got trapped because of the Asian summer monsoon anticyclone. This is the very classical figure of the tape recorder effect. This is from the Newell and Goldstewart in the long time 1950 onward. They have investigated. So in the lower atmosphere, the water vapor will be pumped very drastically. As we go to the near to stratosphere, it will be very slow ascent will be there. So instantaneous pumping of the water vapor, and in the stratosphere it will be very slow ascent. It will take nearly 10 months to reach to the 30 kilometer at the mid stratosphere. So very slow ascent, and you can see there are a lot of dry air. Not only the water vapor is pumped, there will be the dry air present over here, and this will be linked with the different atmospheric phenomena. So many study has been carried out worldwide, and many paper has been published. If you see, there is an increasing trend in the stratospheric water vapor. I am showing from the Mars satellite from 1990 to 2019, and in the near to the tropopause, because it is purely controlled by the tropopause temperature. So near to the tropopause, because of the saturation mixing ratio, because that there is a maximum amount of water vapor which can hold. So this is showing as a tropopause variability. But if you go to the 28 kilometer, 38 kilometer, or even into the mesosphere, there is an increasing trend in the stratospheric water vapor. So it is not only the tropopause which is controlling the stratospheric water vapor, but there are the different other mechanisms are there. This is a satellite observation, and this is a long-term observation from the boulder, from the frost point hydrometer, but it is an in situ observation. This is the global, that is zonal mean over the tropics plus and minus 5 degrees. So I have shown the previous slide. I am not going much detail. If you can see, there is a very one-to-one, like a tropopause temperature and water vapor is matching one-to-one. That is near to the 16 kilometer. And now if you see the right hand panel, there is the water vapor, though even the tropopause temperature is there, but there are the enhancement of the water vapor. If you can see, the tropopause temperature is very, very high, but the water vapor is not that high as we expected. So again, there is a different mechanism. So there is a different mechanism which was proposed by us. Now coming to the ENSO condition, because during the cold and warm phase, you can see the La Nina and El Nino condition, and you can see the water vapor, the very dry part is present over this location because of the tropopause temperature is very cold. But if you see the El Nino condition, there is a warm condition, the tropopause temperature as high as that of the previous one is La Nina condition. The water vapor is pumped much more higher to the in the El Nino condition. This is a global mean picture. Though the water vapor in the lower atmosphere is present both the time, whether it is a La Nina or El Nino time, is almost like same. You can see during the La Nina time more amount of water vapor is present as compared to the El Nino time, but still during El Nino time you are having the more stratospheric water vapor. So I want to say that when you are going for the trend analysis of any parameter, that is mostly for the stratospheric water vapor, directly we cannot go for the zonal mean, though there are paper published that we have zonal mean, but these are the effect which again it will give like a noise in the signal, and we are misinterpreting that yes, stratospheric water vapor is keep on increasing. So not only the El Nino La Nina, if you the El Nino La Nina is linked with means merged with the QBO, because QBO warm and QBO have a ascending and descending phase, which will have a warm and cold, and there are the 2016-17 in between. Here we have a there is a disturbed El Nino, there is a disturbed QBO things, and along with the El Nino was occurring. So you can see the maximum amount of water vapor was in the stratosphere. So no, whenever there is a El Nino condition, El Nino was very, very strong, as well as the QBO disturbed condition was there, and more amount of water vapor was pumped to the stratosphere. Now coming to the QBO regressions, like we have done the QBO regression between the cold point tropopause and the QBO, and you can see there are the places where QBO is matched with that cold point tropopause temperature, which is controlling the lower stratospheric water vapor. But if you compare with the ENSO, these are the two places like a gill structure will be forming over that location. When it is anti-correlating, you are not having much temperature changes, temperature controlled by the QBO. So whenever the ENSO is present, the more amount of means the more influence is by ENSO rather than the QBO. So then the water vapor mixing ratio, you can see over this region is a very, very high you are getting because of the when it is linked with the QBO. So water vapor is linked, as I shown in my first slide, that these many different parameters are there which can be done. Now coming to the diurnal tides, because these are global mean diurnal tides, you can see this is a well known thing that we have a diurnal tide. So what is happening to the stratospheric water vapor in the diurnal tides? And I have taken mostly the Asian summer monsoon region, and you can see the tidal structure is reproduced in the water vapor in the stratospheric water vapor. As I said, it is well one-to-one matching when the tropopause temperature in the near to tropopause, but it is having a anti-correlation, means the opposite phase when it will go to the mid stratosphere. So what was the main condition is that in the mid stratosphere, the water vapor is mainly produced by the methane oxidation, and you can see the solar zenith angle and the OH radical. OH radical is formed from the water vapor and the methane oxidation. So then the H2O will be formed. Actually, ozone H nu, and you will be getting the OH radical from the ozone, OH radical from the ozone, and you are having OH radical with the methane, and you will get the methane oxidation plus water vapor. So most of the time, water vapor when the solar zenith angle is near to 0 degree, means noon time, you are getting the more water vapor, which was shown in my previous figure. This is an amplitude, just to detect the amplitude. And then after that, we have done the theoretical calculations that how much water vapor can be reproduced with the methane oxidation, and it is the theoretical estimation is exactly matching with the 0.4 ppmb from the methane oxidation. So the theoretical estimation, it was in the 2 decimal, I have just put in the 1, so it is matching with the observation whatever the theoretical estimation is there. And we try to estimate with the SB dot how much contribution to the radiation budget. So we have come with that the radiation budget from this will be nearly 0.4 watt per meter, so 0.3 to 0.4 watt per meter from the diurnal variability from the stratospheric water vapor. So the main point I wanted to emphasize here that the stratospheric water vapor is influenced by the mainly factor by the cold point tropopause, convection, Walker circulation. But apart from that, the one of the three main part is that ENSO, QBO, and even the diurnal tides, the tidal oscillation. So global mean stratospheric water, so increasing trend, but we have to remove this parameter from that, which we are in the process of doing that, because we cannot do easily that removing. So we are removing that one and try to find out that one. So this is a systematic phase, and the net radiation budget even from the diurnal tide was 0.4 watt per meter square to when there is increase of the 0.4 to 0.6 ppmb in water vapor in the stratosphere. Thank you very much.
Thank you, Siddharth. Now the presentation is open for questions, if any. Just we will see the chat box.
Hello.
I don't see any specific question, but it was very elaborative talk. And
I have Subbu, I have raised the hand and want to
please quick question, Somji.
Yeah. Basically, Subbu, very nice comprehensive presentation. Just only 2 points are there. One thing is like that 65 kilometer cannot be treated into stratosphere because it is well in the mesosphere. And even 50 kilometer is if stratopause height is taken average 48 kilometer, that also comes into the mesosphere. This is just small these things. And another thing, 28 kilometer you showed that water vapor pumped from down. So that ozone, how ozone chemistry, basically the temperature and other things got modulated because excess of water vapor. Can you just comment on that?
Yeah, actually, sorry, actually, I think it was a sleep. It was the mesospheric height I was talking about. That one, that is a 60.
Yeah, but you told stratospheric.
Yeah,
That's what I
that
got.
maybe I missed one. That is then.
Yeah.
And actually, this in the whenever there is a OH radical formation will be there. So there will be the formation as well as the distraction. Both will be there in the stratosphere. So one is coming to the water vapor formation from the methane oxidation. Then again the OH formation, because that is like a positive feedback will be there. That OH radical will be helping to the distraction of the ozone, because that the Chapman reaction distraction will be there.
Yes. That's
so
what
that distraction will be there, but mostly the water vapor which is from the lower atmosphere will have that most OH radical formation there, rather than the methane oxidation which is already present at 30 kilometer height.
Okay, thank you, Subbu.
Thank
nice
you. Some also minor comment is there from Ramesh. Maybe I think he has in fact appreciated the talk, and he said, interesting to know the tides are increasing, the water vapor or increasing water vapor is causing increasing tidal amplitude. A quick response from Siddharth.
Yeah, actually this whatever the this is, we cannot directly comment that the tides, because the tides things, whatever tide we are observing is based on the temperature. So once the temperature increases, your the capacity, holding capacity of the water, because saturation mixing, if you take near to the tropopause, it is just a function of temperature only. So that maximum amount of water vapor will be actually residing there. So that's why we are getting a tidal structure, but this is not a tides what we observe in the water vapor, in the stratospheric water vapor. It is a tidal structure we are observing because of the temperature.
Thank you, Siddharth. Thanks for your quick clarifications. Now we will move ahead, and may I please request Dr. Salim Ali from SRM Institute of Science and Technology to make his presentation. He will be talking on the effect of cirrus on the thermal structure of TTL inferred from micropulse LiDAR and radio sonde observations. Over to Dr. Salim Ali. Do we have Salim Ali here? I don't see Salim Ali. Once again, I repeat, Mr. Salim Ali from SRM Institute of Science and Technology, Kattangulattur. I think LOC, I think probably this presentation is absent. So we will move ahead, and we will take up the next presentation, that is by Maria Emmanuel from SPL VSSC ISRO. She will be making a presentation on in situ observations of supersaturation and its association with cirrus clouds over the Indian region. LOC, may please permit Maria. Maria, you can load your presentation, please. Yeah, Maria, your slides are visible. Make it full screen. Yes, it's full screen visible. Please go ahead.
Okay, sir. Sir, am I audible, sir?
You are audible and your slides are visible. Please go ahead.
Okay, thank you, sir. Good afternoon, everyone. Myself, Maria Emmanuel. I'll be presenting the results of the in-situ observations of supersaturation in the UTLS region and its association with cirrus over the Indian region. Thank you for giving an opportunity for presenting in this platform. I'll start with an introduction to the tropical troposphere and lower stratosphere region. As we all know, the tropopause is highest over the tropics at reaching at an altitude of around 17 kilometers. In fact, in tropics, the tropopause is not just an altitude, but it's in a layer called the tropical tropopause layer, extending from the convective tropopause around 12 kilometers to the CPT. There is a cold point tropopause approximately 17 kilometers in altitude. So I'll be mainly talking about the water vapor, its saturation, and cirrus clouds in the upper troposphere region, that is from 8 kilometers to the cold point tropopause mainly. So the main source of water vapor in the upper troposphere, mainly the TTL, is the deep convective clouds, as we already have seen from the slides of Siddharth and Gada sir. So the main deep convective clouds will be carrying the water vapor from the source region at the surface to the upper troposphere. So along with the deep convective clouds, in the upper troposphere near the tropopause, there is a presence of cirrus clouds also. That they are thin ice clouds, which has a major role in the hydration and dehydration of the TTL, and a role in the amount of water vapor that is entering into the lower stratospheric region. So apart from that, there is a presence of the planetary waves also in the TTL, which will modulate this supersaturation and saturation processes in the upper troposphere. So I'll be mainly talking about the supersaturation and the cirrus clouds over the Indian region. Why Indian region? Indian region is unique as it is the region experiencing the largest annual migration of ITCZ, and in the monsoon season, it is characterized by the deep convective clouds, very deep convective clouds over the Bay of Bengal region, and the monsoon dynamics such as strong tropical easterly jet and anticyclone circulation will modulate the water vapor and the other tree species in the upper troposphere region. And along with that, there are deep convective thunderstorms in the pre-monsoon and post-monsoon season, also in the over the Indian monsoon region. In this contrast, SPR has conducted in situ accurate in situ measurement of water vapor in the over the Indian region at particularly at 4 stations. The stations are selected in such a way that one station, that is a Kolkata region, it will be coming very near to the deep convective peak during the summer monsoon season, and Hyderabad, which is coming at the fringes of the deep convective peak of the Bay of Bengal, and Trivandrum very away from the deep convection over Bay of Bengal. So in this context, I will be mainly talking about the water vapor measurements from these 4 stations. These 2 stations, that is over the IIT Kharagpur and Kolkata University, I'll be treating as Kolkata and Hyderabad and Trivandrum. So coming to the instrument, I'll be mainly using the cryogenic force point hygrometer observations. Cryogenic force point hygrometer is an in situ accurate measuring instrument for water vapor, mainly working on the principle of steel mirror principle. It will be measuring the force point temperature, which will be converted to the water vapor mixing ratio and relative humidity with respect to ice. In this study, I'll be mainly talking about the relative humidity with respect to ice. The accuracy of the CFS measurements force point temperature is approximately 4.5 Kelvin, and coming when it converts to the relative humidity, it will be around 4% in the surface, 5 to 7% in the upper troposphere, and approximately 10% in the lower stratosphere. And this is a typical profile which we obtained from Trivandrum on 17th of April 2014. The left panel shows the ambient temperature and the frost point temperature. That is blue is ambient temperature and the red is the frost point temperature. Whenever this frost point temperature becomes equal to the ambient temperature, we call it as saturated. So when the frost point temperature is equal to or greater than the ambient temperature, that is in the saturated condition, there is a high probability of the formation of clouds. So this is similarly I am showing the water vapor mixing ratio and saturation mixing ratio also. This is another representation of the same thing. Whenever the water vapor mixing ratio becomes equal to the saturation mixing ratio, saturation occurs. So I'll be talking in terms of the relative humidity with respect to ice, which is the ratio of the water vapor mixing ratio to the saturation mixing ratio multiplied by 100. So 100 means 100% RHI means that saturation is occurring, and whenever RHI is greater than 100 meter, it is supersaturation. So in this profile, we can see that at this altitude, around 12 kilometer, we can see a supersaturated layers. So similarly, I took 3 cases, that is on 17th April 2014, 13 May 2014, and 28th of May 2014. The latent humidity with respect to ice is shown in the left panel, that is this panel. So whenever there is a latent humidity with respect to ice crosses the 100%, we can see the presence of cirrus clouds from the calypso observation. There is a backscatter coefficient from the calypso observation. So the main objective of the study is to study the covariance of the supersaturated layers and cirrus in the upper troposphere over the Indian region. Wind data sets used as actually already told with us the cryogenic phosphoine hygrometer data, and as supplementary I have used other data sets also. Coming to the relative humidity with respect to ice, the seasonal variation, that is winter, pre-monsoon, summer monsoon and post-monsoon season, there is a frequent occurrence of supersaturation in the upper troposphere layer, that is greater than 100 meter. It is same case with the Hyderabad and Kolkata region. In the upper troposphere region, we have frequent occurrences of supersaturation layers. So I have calculated the occurrence frequency of relative humidity with respect to ice greater than 100%. That is the occurrence frequency of RHI greater than 100%, and it's shown as the bar diagram. Along with that, the occurrence frequency of cirrus clouds from calypso and the tropopause altitude and temperature from cosmic is also seen. If you look, the relative humidity with respect to ice, RHI greater than 100%, shows multiple peak structure in the upper troposphere region. Mainly, two peaks are seen. One very almost in the altitude region 12 to 13 kilometer, and another in the altitude region 15 to 16 kilometer. This is mainly prominent in the pre-monsoon and post-monsoon season, and also in the post-monsoon summer monsoon season. In summer monsoon season, there are multiple peak structures are also seen. But if you are looking into the cirrus occurrence, it shows only a single peak structure. So, also in this figure, we can see that there are occurrence of supersaturation above the CPT also. From the mean picture, if you are looking, there is occurrence above the CPT also. So we have looked into that, and the occurrence of supersaturation above CPT is very less. Still, there is a presence of supersaturation up to 1 kilometer above the CPT is seen. That is also maximum during the pre-monsoon and summer monsoon season. So from this slide, the point is that the relative humidity with respect to ice shows a double peak structure, but the occurrence of cirrus clouds is showing a single peak structure. So we have looked into the occurrence frequency of cloud base and cloud top. But from this observations, we can see that the cloud-based structure also shows a multiple peak structure, even though the secondary peak, that is the higher peak, is not that prominent during the summer monsoon season. It is also showing a double peak structure, but the cloud top is showing a single peak structure with a peak around 16 kilometers. This indicates the probability of existence of two layers of cirrus. One, a lower layer which is somewhat thicker, that is 4 to 5 kilometer thicker, and an upper layer of 1 to 2 kilometer thickness. So in order to check this hypothesis over the Indian region, we have divided the occurrence of cirrus clouds into two. That is the cirrus clouds with cloud base less than 14 kilometer and that with cloud base above 15 kilometer. This shows the occurrence, the mean cloud base altitude, the mean cloud top altitude and mean thickness of the cirrus cloud with cloud base less than 14 kilometer. If you are looking into this occurrence, we can see that the occurrence frequency of clouds, anyway, it peaks during the summer monsoon season itself. And if you are looking into the seasonal variation of deep convection from Kalpana, we can see that the occurrence frequency of cirrus with cloud base less than 14 kilometer is having a close association with the occurrence frequency of deep convection, but the occurrence doesn't peak just above the occurrence of deep convection peak, but around the surrounding regions. This indicates that these clouds are mainly from the deep convective origin, that is the cirrus clouds formed by the anvils of the deep convective clouds. Now coming to the next thing, there is a cirrus cloud with a cloud base greater than 15 kilometer. If you look, the occurrence frequency of these the cirrus itself is lesser. the maximum is coming around 60%. But if you look, it doesn't have a direct connection with the deep convective clouds. But if you're looking to the occurrence frequency of supersaturation from MLS, this pattern very well matches with the spatial variation of the occurrence of supersaturation from MLS, especially during the summer, the June, July, August, September, which indicates that these clouds, which are having cirrus clouds with cloud base greater than 15 kilometers, should be of in situ origin, which is formed either by the homogeneous or heterogeneous location. But from this, we cannot distinguish whether it is due to homogeneous or heterogeneous nucleation. The previous studies have shown that for the homogeneous nucleation, at least a supersaturation of around 160% is required. But we could only find only 2 cases from the whole 100 CFH profiles, one over Hyderabad and one over Kolkata, satisfying that criterion with supersaturation greater than 160%. But unfortunately, we couldn't have collocated occurrence of Calypso, so I am not showing. So with that, anyway, we can infer that this cirrus cloud with cloud base greater than 15 kilometers, it should be of in situ origin, either of heterogeneous nucleation or homogeneous nucleation. With that, I conclude my studies. The main conclusions are the occurrence frequency of RHI shows a multiple structure, mainly 2 peaks, one at approximately 12 to 14 kilometer and another at 14 to 16 kilometer in the upper troposphere in all the seasons. Concurrent Calypso observation shows the presence of high altitude clouds, that is cirrus clouds, at the altitudes of supersaturated layers. The cloud base cloud base occurrence also shows a double peak structure, indicating two layers of cirrus clouds with a thicker layer in the lower altitude and a thinner layer in the upper altitude. The CFH observations also reveal the presence of supersaturated layers up to a kilometer above the CBD temperature. The deep convective and relative humidity with respect to Aries observations show that the lower cirrus layer is closely associated with the deep convective onflows, and the upper layer must be associated with the that of in situ origin. Thank you.
Thank you very much, Maria, for keeping the time and elaborating a very detailed study on making use of in situ observations from more than 3 stations. The results are quite impressive. May I take some couple of questions, if any, from the chat box or the audience? Those who may like to ask a question can raise their hands. I don't see any question in the chat box. Anyway, Maria, it was a very impressive talk. And
thank you, sir.
All the very best. It was a very good work. Please keep it up. So we will move ahead. Maybe you can stop sharing your presentation so that we can go to the next presentation. Next presentation is by Priya JS from TKM College of Arts and Science, Kollam. She will be making a presentation on cirrus fraction and cirrus reflectance with respect to precipitation characteristics over the Indian subcontinent. Over to Priya. Your slides are visible.
Thank you, sir.
You can please present.
I'm Priya JS. I'm here to discuss a few observations about cirrus fraction and cirrus reflectance with respect to precipitation characteristics over the Indian subcontinent. And thank you NSSS coordinators for giving me a chance to present my work here. Few words about cirrus clouds. Cirrus clouds are thin wispy clouds, and they are higher altitude clouds found in the range of 6 to 18 kilometers over the tropical regions, which regulates both local and global climate. At any given time, 50% of Earth's atmosphere is covered with the cirrus. Importance or role of cirrus in climate mitigation. Cirrus clouds have attracted considerable interest because of their impact on Earth radiation budget and weather changes. On one hand, it exhibits the albedo effect, and on the other hand, it exhibits the greenhouse effect. Their overall effect on Earth radiative energy budget is not yet fully quantified. Cirrus clouds are detectable not only from the ground-based systems but also from the satellite and aircraft measurements. The current work investigates on cirrus fraction, which is a measure of cirrus cloud horizontal extent. The relation between monsoon-related precipitation and CIF is discussed here. Cirrus reflectance is very important for quantifying the effect of cirrus clouds on Earth radiation budget, as it is one of the microphysical properties which has a dependence on the ice structures present inside the cirrus. The present work investigates the spatial and temporal distribution of cirrus clouds and CIR and CIF and how this relates to the precipitation over the Indian subcontinent. Analysis of data. Indian subcontinent is taken as the region of study with 8 years of MODI's sensor data of Terra satellites from 2013 December to 2021 April, and with the precipitation data from combined GPM emerged. The observation period is classified into 4 seasons as winter, pre-monsoon, monsoon, and the post-monsoon. MODI sensor. MODI's motorized resolution imaging spectroradiometer is a key instrument aboard the Terra and Aqua satellites, provides the capability for globally retrieving cloud properties using passive solar reflectance and infrared techniques. The optical system is the core of the MODIS instruments, which gathers, directs, and splits Earth radiation into 36 spectral bands and a group of wavelengths in which 0.4 to 14.4 micrometers. And the cirrus reflectance in MODIS is retrieved by using channels near 0.66 micrometers and 1.375 micrometers, in which we take 1.375 micrometers. Terra is a multinational NASA scientific research satellite in a sun-synchronous orbit around the Earth, which carries a payload of 5 remote sensors designed and MODIS is one among them. It is launched in December 18, 1999. The specifications of the MODIS sensors. Of geographical regions of India. In this study, the spatial plot of Indian subcontinent is divided into 6 as southern, western, eastern, northern, and the Tibetan Plateau regions. Results and discussions. During January and February, CIF is very low over the southern, western, eastern, and the central parts, and December and almost same value as in December over the northern parts of India. Cirrus fraction over the Tibetan Plateau is very high during the winter season, as these figures indicates the spatial variation of cirrus fraction over the Indian subcontinent during the winter season from 2030 to 2021. Spatial variation of cirrus fraction over the Indian subcontinent during the pre-monsoon season is seen in this figure. And during pre-monsoon season, CIF over the central parts are very low, and CIF over the Tibetan Plateau is very high during the pre-monsoon season. During monsoon season, CIF is high over southern, western, eastern, and central portion and gradually shows a decrease during August, and CIF over the Tibetan Plateau is high during the monsoon season. During the post-monsoon season, CIF gradually decreases over the southern and low over the western region and the northern parts of India. CIF over the Tibetan Plateau is very high during the post-monsoon season also. And these are the spatial variation of cirrus reflectance over Indian subcontinent during the winter season. During the winter season, CIR over southwest, east, and central parts of India have low over northern parts. CIR also increases. CIR over the Tibetan Plateau lies between 0.0889 to 0.22 during the winter season. And during the pre-monsoon season, there noticed a lowest value of CIR over the western parts. But over the northern parts, the maximum value noticed in March, and afterwards there is a gradual decrease in CIR. And CIR over the Tibetan Plateau lies between 0.0889 to 0.22 during the pre-monsoon season. During the monsoon season, there noticed a lowest value of CIR over the western parts on June, and then gradually increases during July and August. Increase in CIR is noticed over the southern, eastern, and the central parts of India, but over the northern parts, there noticed a constant increase throughout during the monsoon season. CIR over the Tibetan Plateau show a decrease in value, which ranges between 0.044 to 0.1133 during the monsoon season. These are the spatial variation of cirrus reflectance over the Indian subcontinent during post-monsoon season from 2014 to 2020. During post-monsoon season, for all parts of the Indian subcontinent except the northern Indian region and the Tibetan Plateau, there is a decrease during the near end of the post-monsoon season. Using the linear regression analysis, the plots of cirrus fraction versus rainfall, cirrus reflectance versus rainfall, and cirrus fraction versus cirrus reflectance is fitted using a straight line. All years plots show a highly linear fit. These plots also shows a good Pearson correlation value, and this positive correlation suggests that precipitation has a role in determining the CIF and CIR. The temporal variation study of cirrus fraction and precipitation shows that a strong temporal coherence among them. As precipitation increases, cirrus fraction also increases, is shown in figure 1b. The month of July is a convectively active monsoon period with the transportation of aerosols and water vapor from water bodies to the land. The vertical transportation of moisture-rich monsoon season. Aerosols has cirrus formation during the monsoon season. CIR also shows a similar trend suggesting the presence of ice clouds, shown in figure 2b. As the number of cirrus clouds increases, there is a net significant increase in cirrus reflectance also. These are the summary of the work. CIF is higher in the southern and northern regions of the Indian subcontinent. The central India shows comparatively less CIF with respect to other regions. Even though CIF is less, it follows a similar seasonal distribution of monsoon maximum and winter minimum. The southern, western and eastern parts of India show a CIF of 0.44 to 0.889 during the monsoon and decreases to 0.11 to 0.556 during the winter period. The cirrus fraction is maximum during monsoon all over the Indian peninsula and gradually decreases after the monsoon and reaches the minimum during the winter period. The Tibetan Plateau shows strong cirrus fraction throughout the seasons except during monsoons, and the strong presence of cirrus fractions may be due to the mechanism of topographic lifting. Cirrus reflectance for clouds observed in the larger central part of India is very less when compared to other parts of the India except during the monsoon. From the regression analysis, it is found that CIF and CIR and the precipitation shares a mutual positive linear correlation having high Pearson coefficient. From the observations, it is understood that even though CIR shares highly linear relation with the CIF throughout the Indian subcontinent, the same relation cannot be considered while studying the localized regions. So this localized effect might be due to the influence of weather conditions prevailing over the region at that time. These are the references used. Thank you.
Thanks a lot, Priya, for making a very crisp presentation, and it is quite heartening that very good usage of the MODIS data. And I'm also impressed with the domain of your expertise that you are gradually expanding to the cirrus and its impact, and also presenting a morphology in a crisp way. Do we have any questions either in the chat box or from the audience?
I will ask one question.
Yeah, my colleague Kishore has a question.
Priya, I have seen your presentation. Have you ever explored Calypso data, which will give the vertical structure of cirrus? That we will have a very good handle.
Yes, I make a plan to compare these two data between the MODIS and the Calypso data.
Yeah, Calypso will be giving you a very good morphology of vertical structure. Yeah.
Yes, sir.
Okay.
Yes.
Okay, thank you, Priya. And also, I will be encouraging you that in future, probably if you make use of our Indian satellites data,
sure,
which you can always download from MOSDEC and Bhuvan and also from IMD website, it will add up more flavor to your results because it is very good. And I wish you all the very best. I think your institute will be carrying good work ahead. Thank you for your presentation. You can now we will move ahead to the next presentation. Next is by Aditya Jaiswal from Aries Nainital. He will be making a presentation on the characterizing the layers of enhanced turbulence using VHF radar over the central Himalayan site. I think it is kind of sequel to the very first presentation made by Samiresh Bhattacharjee. So welcome Aditya, you please load your presentation. Over to Aditya. Aditya, you may unmute yourself and load your presentation. Maybe LOC can help Aditya in loading his presentation.
We won't be able to load.
Aditya, can you hear us?
We are looking into it.
Yeah, I think because he is already in the presenters list. So Aditya, can you listen to us? If you are unable to speak, can you put a word in chat box? In case you are able to listen to me. Or probably what I will do is I may request LOC to, we will go ahead with the next presentation and we will take up Aditya's presentation after the next one, because right now we have some technical problems in getting him in. So we will make use of the time and I will request Anjana from SPL to make her presentation. But again, let me again remind, we will take up Aditya's presentation after Anjana's presentation. Because of the technical issues right now, I will be allowing Anjana, who will be making her presentation from my terminal only. So Anjana will be giving a presentation on a new approach to explore Hadley cell dynamics at regional scales using radio occultation techniques. Aditya, you may remain with us. We will take up your presentation after Anjana's presentation. Over to Anjana.
Am I audible and is my presentation visible?
The
LOC,
presentation
can
is
you please confirm whether her presentation is?
She is audible, but the presentation has not come up yet.
Okay, we will.
I think share, right? Share.
Yes, we can see the presentation now and it is in full screen mode. So you can go ahead.
My presentation is entitled as New Approach to Explore Hadley Cell Dynamics at Regional Scales Using Radio Occultation Technique. First, I will briefly explain Hadley circulation and radio occultation one by one. Now, in order to understand Hadley circulation, we need to understand atmospheric circulation. Which is caused because of the fact that the sun's rays reach the Earth's surface at different angles, and also due to the fact of that there is a tilt in Earth's axis of rotation. So the tropical areas receives more amount of heat where compared to subtropical and polar regions. So there has to be a heat transport mechanism from the tropics to the subtropics and polar regions. In nature, this is accomplished with the help of atmospheric and oceanic circulations. And Hadley circulation is the largest atmospheric circulation, responsible for tropical as well as subtropical climate. Now, going to Hadley circulation in depth, the rise of the tropical moist air ceases at the tropopause level, and then it goes towards it diverges towards both hemispheres, and in this path, the air radiatively cools and it loses moisture and it becomes dry air, which sinks at the subtropics, making the subtropical areas dry and parched in climate. Then it completes the Hadley circulation through trade winds. The trade winds converges at the intertropical convergence zone called ITCZ, which is an important feature of the Hadley circulation because of its precipitation as well as cloudiness. Now, the phenomenon that I'm addressing here is Hadley cell expansion. Now, the main question that arises in our mind will be, why does the Hadley cell expand? Although there are many anthropogenic as well as natural causes for Hadley cell expansion, it is mainly attributed due to global warming. Then, how much does the Hadley cell expand? Actually, observationally, it is determined to be about 0.25 to 3 degrees per decade, but it is recently corrected to be about 0.25 to 0.5 degrees per decade, taking into account of the global climate model simulations. This accounts for around 250 to 500 kilometers per decade. The consequence of Hadley cell expansion, because the descending regions of the Hadley circulation are deserts or generally dry and parched areas, the subtropical dry zones will be shifting forwards as the Hadley cell expands. How far has the previous studies done in this field of research? Most of the previous studies have given a zonally average picture of Hadley cell expansion. In this study, I will give a zonally resolved picture, that is for the longitude. For every longitude, what is the expansion consequences? Coming to the relevance of my study, decreased amount of precipitation and increased frequency of occurrence of droughts in the highlighted regions are divulged as consequences for the Hadley cell expansion at regional scales. Coming to data and methodology, I am using cosmic data for the characterization of Hadley cell boundaries, zonally resolved Hadley cell boundaries. Cosmic work using the principle of radio occultation technique. The radio occultation is a communication between GPS satellite and the lower Earth orbiting satellites through radio signals. The radio signal transmitted from GPS to LEO satellite gets occulted by the atmosphere, and there will be a Doppler shift in the received signal, which then is converted into bending angle with the help of geometry, as well as it is a limb viewing geometry, and then it is converted into refractive index using Abel's transform, and then converted into refractivity using this equation. Then atmospheric properties are retrieved using radio occultation technique. These are the data sets used in my presentation, used in my study. First is Aerosol reanalysis data with monthly mean meridional winds gridded into a resolution of 0.25 degrees in 37 vertical levels, ranging from 1000 hectopascal at the surface to top of the atmosphere at 1 hectopascal. Then cosmic GPSR observations, global positioning system radio occultation, observations of temperature, pressure, and water vapor profiles extending up to 40 km with a vertical resolution of 100 meter. It is gridded into 2.5 by 10 degrees. Then Gpcp data set gridded in 2.5 degrees from 1979 to 2020. The data consists of range gauge stations, satellites, and sounding observations merged together. The main time period used in our study is 2007 to 2015, 9 years. The strategy of my study is to retrieve the zonally average Hadley cell parameters from cosmic GPSR observations and validate with RFI. Then the results indicate good agreement, and then it gives us confidence to retrieve the zonally resolved parameters using cosmic GPSR observations. Now, this is the method used to derive Hadley cell zonally average parameters from RFI using the metric MSF or meridional masking function. It is given by this equation. A typical plot of MSF for northern hemisphere winter is seen here. Positive value indicates clockwise and negative value indicates counterclockwise circulation. The crucial point in calculating the Hadley cell edges from MSF is that we are taking the MSF at 500 HPA, and then at the it looks like a similar to a sinusoidal curve. So the middle center of the curve is taken as the Hadley cell center, and the maximum and minimum towards both sides is taken as the edge of the ascending region. Then the zero towards both hemispheres are taken as the edge of the descending region. So this is the zonally average ascending region, and this is the zonally average descending region of the Hadley circulation. And this is the methodology followed in calculating the same, that is zonally average Hadley cell parameters from cosmic. First of all, cosmic gives temperature profiles, which is gridded and monthly averaged. Then elapsed rate of topopause is calculated using standard procedure. Then bulk static stability, that is the potential temperature difference between the surface and the elapsed rate of topopause is calculated. Then the maximum latitude corresponding to maximum bulk static stability latitude gives the Hadley cell edge. Then water vapor distribution is given by cosmic and is converted into relative humidity distribution using standard Graf-Rach equation. Then relative humidity maximum corresponding latitude is given as taken as Hadley ITC at center. Then the Gaussian fitting is given to the relative humidity versus latitude curve, and then we take the full width at half maxima as ITC set width. Zonally resolved analysis using cosmic is done using the same methodology, but the data is seasonally averaged before applying the procedure. Coming to results and discussion, here we have validated the zonally average Hadley cell parameters calculated using cosmic using the standard RFI reanalysis data.
Because the results are in good agreement with each other, we decide to zonally resolve the Hadley cell parameters using cosmic observations. This is the ITCC parameters retrieved purely from cosmic GPSR observations. Here we have taken the relative humidity at 5 km and made a Gaussian fit with the maximum relative humidity giving ITCC center and the full width at half maxima giving the width of the ITCC. Comparing both the seasonal plots, we see that the amount of relative humidity is more in the summer monsoon season, as well as the interannual variability is also more. This is the zonally resolved descending region of the Hadley circulation, and this is the ascending region of the Hadley circulation. The green line denotes the zonally resolved edge of the descending region, and blue denotes the edge of the ascending region, which is same as ITCZ width, and red is the ITCZ center. Comparing the two maps, we see that there is ITCZ migration during the summer monsoon season. Here we have added one more data set, that is Gpcp precipitation data set. It is plotted along with the maps, along with the Hadley cell boundaries. The white areas denote the precipitation less than 0.2 millimeter per day. It is confirmed that the descending area of the Hadley circulation comes under the descending branch that we have calculated. Then we have analyzed the precipitation trends using Gpcp. It is found that there is a zonal non-uniformity in the trends, and that most of the trends in the descending region of the Hadley circulation are descending trends. So it is confirmed to be an expansion of Hadley cell. Expansion is happening. These are the conclusions. A method is proposed to delineate zonally resolved ascending and descending branch of the Hadley circulation using cosmic GPSRO measurements during 9 years of 2007 to 2015 for the first time. This method is validated using the Hadley cell boundaries derived from MSF metric using ERA5 reanalysis data, and the results were in good agreement. Zonally resolved ITCZ center and width, same as Hadley cell center and ascending region, are estimated using relative humidity distribution and shows ITCZ features well. Regional impacts of Hadley cell expansion are investigated using precipitation dataset. Precipitation trend that shows a zonal asymmetry over the ascending and descending region of the Hadley circulation. Thank you.
Thank you very much, Anjana, for a very nice and crisp presentation. Straight to the focused way on the Hadley cell. We will take up few questions in the chat box. Any questions to this presentation? Yeah, I think there is a question from Ratnam. He has put a question on cosmic data might already gone in ERA5. It is already expected to compare well. What is your response, Anjana? You can speak there.
Even though ERA5 has cosmic embedded in it, we are using cosmic as a method to zonally resolve the Hadley circulation edges, which is not possible with ERA5 dataset because of the metric, that is MSF is a zonally average metric. Thank you. I hope your question is answered.
Yeah, I think that is good. Also, maybe like I may like to give a minor suggestion that as you showed in your results, you have made use of the pressure levels data of ERA5, starting from 1000 to 1 hectopascal. But if you may prefer to have more fine resolution data, as ERA5 runs in 137 levels, and if you go directly download the model level data, sometimes you may be able to get more features what you may not be getting in the pressure levels. But otherwise, it is a very good study. Thank you, Anjana, for making this presentation.
Thank you, sir.
Now, we will take up the next presentation. Actually, it is by Aditya Jaiswal. He had some issue in the presentation. Is Aditya available now? Aditya, am I audible?
Hello, sir. Am I audible?
Yeah, you are audible. Can you please load your presentation?
Okay, sir. So is my presentation loaded?
We are waiting. Let us wait. Sometimes it comes. Have you shared the full screen?
No, sir, I haven't shared till now. Is my presentation visible?
Right now it is, yeah, it's not visible. How do I help you here? You have to click the share button and then press the desktop.
Yes, sir. That's what am I doing. I have done the open share tray, and then I've gone to window, and then I'm selecting my screen.
Desktop, I think it is here. LOC can comment.
Yes, it is advisable that you use the entire desktop option after you click on the Open Share Tray button. That allows you to share the entire desktop. Can you try that?
Okay, can you see it now?
Not yet.
Hello.
Are you clicking on the Open Share Tray button?
Yes, ma'am. I'm clicking on that button only.
So, do you get an option? The first
I'm
option.
getting two options: desktop and then window.
So
And
please click on the
then
desktop
I
option.
click on desktop, and but after that,
After choosing that on the top, I think you have to click the PPT.
okay, I've clicked my PPT, clicked on my PPT, but it is not visible to you, I think.
Mr. Aditya, can you tell us what exactly you are seeing after selecting the desktop option?
After after selecting the desktop option, uh, actually, uh, nothing is happening. I mean that my desktop screen is not visible to you, uh, uh, even after I'm selecting the desktop.
So, uh, have you clicked on the Open Share Tray button
Yes.
before selecting that? So, can you leave and join again and try this once more? Maybe it's some technical
Okay.
issue.
Okay.
Maybe we
Yeah.
will wait. Aditya, can you quickly log out once and
Okay.
again join back?
Yes.
In the meantime, since we have some time with us, I may just like to check, as I see from the audience, our time is up to 4 o'clock and we may have some time. So whether Mr. Arvind Vale from SRM Institute of Science and Technology, whether he is available here? Can we allow him? Can you put in a chat box if you are available? Yes, he is available. Our LOC, can you please permit him to speak for a while? Arvind Vale.
Yes, we
You
have
may,
given him the microphone option.
Arvind Vale, can you listen to me? You may unmute Arvind Vale. I can see in the chat box you are available, and I think LOC has given permissions to you to speak as well. Still a presenter mode. I think you can speak probably. No, he is in the attendance only.
Hello. Hello, sir. Am I audible?
Yeah, is it Aditya Jaiswal? You are audible?
Yes, ma'am. Can you see it? Yes, sir. Can you see my screen now?
Not yet.
The screen is not visible yet. Aditya sir, can you tell us which operating system you're using?
Windows I'm using only. I'm using Windows only.
Okay, then after selecting the
Yeah, actually, from Aries, Samresh had made a presentation. I do not know where. Maybe if possible, if you can go and give it from there also is fine. Otherwise, it looks to be a minor issue, but unless we fix it up. While we try to fix up whether Arvind will, I think you can listen to me. Will it be okay if we take up your presentation in the session A?
Yes, sir. Sure. It's audible, sir.
Is it
Hello.
Arvind will?
Hello, sir. Yes, sir. I'm Arvind Vil.
You are okay. Is it okay if we take up your presentation now?
Yes, sir. It's fine, sir. Fine, better, sir.
Aditya, so will you give a try maybe once again or?
Okay, sir. Okay, sir. I will.
What I
I'll,
suggest, Aditya, is since just before you, your colleague Samresh has given a talk, so
okay,
if
sir. I
you
will try to
can,
give it from here.
if you can quickly transfer your presentation there and make up. We will take
Okay.
Arvind Vale's talk in next 15 minutes, and we will try
Okay.
to take your talk immediately after that. Okay.
Okay. Hmm.
So I request LOC. I think already LOC has permitted Arvind Vale as a presenter. I'm sorry for this arrangement, but let us make use of the time. So I
Okay.
request Arvind Vale from SRM Institute of Science and Technology, and I request him to make his presentation on long-term changes in aerosols and its impact on cloud temperature and rainfall over northeast monsoon region, Chennai. After his presentation, if Aditya can fix up his things, we will take up his talk. Otherwise, we'll try his talk later. Over to Arvind Will. Please present your results maybe in 12 minutes. Over to Arvind Will. We can see your slides. You may unmute yourself and speak.
Yes, sir. Now it is audible, sir.
You are audible and your slides are visible. Go ahead, please.
Thank you very much, sir. So, good evening to everyone. Myself, Arvind Vil, working as a senior research fellow in Atmospheric Observation Modeling Laboratory, SRMIST, Katangalatur. The title of my talk is Long-Term Changes in Aerosol and its Impact on Cloud, Temperature and Rainfall over Northeast Monsoon Region. I will start with small introduction. So, as we know that atmospheric aerosol has a variety of as we know that atmospheric aerosol have multifold due to its impact is multifold due to its direct, indirect microphysical reduction and other dynamic interaction. However, the order of estimation is still highly uncertain due to the lack of observation datasets and inadequate spatial and temporal and vertical information over the globe. So during a past decades, the intense observation from Indian region have yielded the wealthy informations like long-term properties, radiative forcing, and etc. However, most of the available information suffers mainly due to the coarse resolution and inadequate spatial information. Inadequate spatial information. Oh, it is moving. Okay. Inadequate spatial information different. So there is a much essential to estimate the long-term. It is automatically moving. Okay. There is much essential to estimate the long-term effect of aerosols over different part of Indian region to better understand the aerosol impact on the regional scale. So in this present context, I aim to study the aerosol impact on the northeast coastal station, tropical coastal Katangalatu, which is shown in the slide in the figure A. It's under the blue line and the red line is marked. It shows the calypso passes, which I have taken the vertical observation of the aerosol extinction profile. And figure B represents the topography of this study site, which is you can see that study site is located with small hills, and the study site was marked with a black dot. It shows in the Katangalatu region, as well as it is also marked with the X marker, which is a IMD Chennai radio sound station, where I have taken the temperature observation and over the period of long term. And so mainly the objective of the present work is to study the variability of aerosols, cloud, temperature, rainfall, and as well as the relation between the aerosol with the cloud, temperature, rainfall, and finally the long-term trend in the observed variables. So in this context, I have for the aerosol for aerosol data, I have used the Calypso and Modis datasets, and for cloud data, I have used from Modis observation. For IMD, for rainfall, I have used the IMD datasets, and temperature, I have used the radius on day from the radius on day over a period of 2001 to 2018. These are the direct parameters, as well as also I have derived parameters. I have used the cloud albedo, and another one, the important parameter is the aerosol cloud interaction, which is or otherwise we can tell that aerosol indirect effect to estimation of the aerosol indirect effect is nothing but generally stating the changes in the aerosol's optical depth with respect to the how the cloud effective radius gets changed in in constant liquid water path, which popularly known as a Tomei effect, to estimate this. And for the long-term trend analysis, I have used two methodology. One is a empirical mode decomposition analysis, which can use the various intrinsic modes present in the long-term nonlinear stationary data. So which can basically it works with it can map the local minima and local maxima, and will take the mean and will subtract from the original data. It will goes continuously when up to the residual it's observed. And further to study the long-term trends, as earlier talks have mentioned, it's any atmospheric data has it's accompanied with the QBO, ENSO, and different factors, solar factors, the natural variability. So in order to remove and to get the actual residual trend, we have to use the
Okay, and
multilinear.
that's what I'm doing right now. I have
Hello. Yes, sir. These are the datasets methodology. So this figure shows the seasonal variability of aerosol, cloud, rainfall, and temperature over the period of 2001 to 2018, and this shows the aerosols and temperature and cloud parameters and the rainfall parameters. So 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 the aerosol optical depth, it varies. We can see that it high during a pre-monsoon season and minimum during a JJAS, which is southwest monsoon season. It is known to be that it's a pre-monsoon season. It's ruled with high convection and advection, and as well as which increases the maximum number of aerosol loading, which leads to the high aerosol it leads to the high aerosol optical depth. And the minimum in the JJAS, it's mainly related to the scavenging process due to the wet scavenging process. And when we see the size parameter of angstrom exponent, it is well known that it is during during winter and post monsoon season, we have a high value which shows the fine mode fraction, and during JJAS which we have a low value which it indicates the coarse mode fraction, and it's mainly ruled by the bound layer dynamics as well as the scavenging process involved together. When we see the bound layer extension from observed from the Calypso data sets, we can get this. It is when minimum during the pre-monsoon and JJAS, and maximum it's observed from the post-monsoon as well as the pre-monsoon season. So it is, we know that it's mainly dominated by the bound layer mechanism, where we can see that during the lowest bound layer observed we experience in the winter and post-monsoon season. So we can traps the more aerosols below the bound layer. So we can see the bound layer extension is very high compared to the pre-monsoon and the JJ and the monsoon season. Whereas it is typically opposite in the free tropospheric extension coefficient, totally reverse, because the during JJAS and the pre-monsoon season we were having the highest convection, and which this convection can pump the maximum aerosols to the higher altitude. So this shows the different pattern between the bound layer extension and the free tropospheric extension. Whereas the variability, if you've seen in bound layer and free tropospheric temperature, it is more or less similar. However, the maximum in the temperature varies it varies from May and June. It seems here. And when we see the cloud parameters, when we see the cloud optical depth and cloud effective radius, then they see the cloud optical depth. We are observed a high cloud optical depth over the post monsoon season, northeast monsoon season, and similar to the cloud effective radius also we are observing the northeast monsoon. So this may causes the highest amount of rainfall over this region. This could be a reason. And whereas typically if you see the cloud fraction and the cloud top height, though even the cloud optical depth and cloud effective radius is high in the post monsoon season, in monsoon season we may have the cloud fraction very high and cloud top height also very high. This is probably known that because of the high convection ruled out during a JJAS, and the cloud liquid water path shows there is a maximum values observed during in the post monsoon season. and which results the highest amount of rainfall over during the post monsoon. So we can see in the variation in the rainfall where this station receives a maximum rainfall, though even maximum rainfall in post northeast monsoon season, also it experiences the JJAS during the southwest monsoon season. So this will give the clear variability from aerosol, temperature, cloud, and rainfall. So now, and how this aerosol have been associated with the cloud. What we have done, we have taken the 2001 to 2018, it's a long-term data, and we have grouped with respect to the every unit of the AOD, and we have done for the we have grouped for AOD with respect with the cloud fraction and cloud top height. What we observed, we have seen the positive linear correlation, which positive linear relationship between cloud fraction and AOD. So which tells us that increasing in the more polluted scenario, the cloud fractions get increases, means it resulting to the maximum number of CCN, and it can widening the cloud fraction. And similarly, we can see in the cloud top height, when the cloud fraction is more wider, and it also because of it's pumped up, so the cloud top height also we have increased slightly in low level clouds we have seen. Whereas in the case of albedo, there is during a low condition and moderate aerosol condition, there is no much change was seen. Whereas in high polluted scenarios, there is a strong increment in the albedo which we have seen. So this may cause us, this may also suggest the possible of reduction in the surface solar radiation, and this basically this deals this evidence that this study site is strongly evidenced by the semi-indirect aerosol effect. And the final panel shows the aerosol cloud interaction, which I have earlier shown the formula and discussed. So this we gives the what we expect that the increasing the air polluted scenario, and when more aerosol is pumped up, it can reduce the cloud effective radius, and it can radius. But it is not actually we seen. It is a disturbed structure. It is so in earlier presentation, even that in earlier days, Suresh Babu sir also mentioned. So what we heard, it is disturbed scenario where the positive values represent the Tommy effect and negative values represent the anti-Tommy effect. So this could be due to the swelling or else the overlapping the cloud effect which we have seen in the respect of. However, there is the positive effect also, in more or less it is 60 to 40% we observe with the Tommy and anti-Tommy effect. So then how this aerosol loading is associated with the temperature? We have taken the bound layer temperature with a mean bound layer height with respect to over the station 2 km. It reported from the Reddy et al. 2020. So we have taken the mean bound layer height, and we have averaged the temperature from surface up to the bound layer height, and the free tropospheric we have taken the altitude up to 8 km. We have grouped together with respect, as I have mentioned, the wind with every unit of the AOD. What we have seen in low value, it is though it is increasing in the bound layer temperature, whereas in high polluted scenario, it goes slight decrement, very slight decrement we have seen. And this pattern is totally opposite to the free tropospheric temperature where there's a slight increment in the temperature also we seen. So what we observe that it tells that there is a this also the reason, and from the possible of different aerosol loading, when the maximum aerosol loading in the free troposphere, which may cause of possible of surface reaching solar radiation, also which we have to deal in more in detail. So we have evidence this that the different in the pattern between these results are consistent with the recent reported the result over the Indian region. Over Ratnam et al. 2020 has reported that the changing in the vertical aerosol trend between vertical pattern of aerosol in higher altitude and within the boundary layer. So next, what we have seen in the how this is associated with the rainfall scenarios. So this higher value shows in first panel shows the AE, where the higher value shows the fine mode fraction and lower value shows the coarse mode particles. So it is steep decrease we have observed when it is known that when the finer mode fraction is going, it can reduce the cloud effective radius, and it can possibly it causes the reduction of the rainfall. And however, it is not as linear, it is straightforward. There is an increment is there. This is mainly because of the high intensity episode were observed evidenced in this over this station. And understanding this, I have gone for the long-term trend analysis. Before going, as I have mentioned, the long-term trend analysis in any parameter which we have seen, it is composed with many functions of natural variabilities and other variables, like for example semi-annual, annual, this kind of. So how to deal? So first panel shows the AOD, and this is the anomaly of this AOD. AOD it is shown. So anomaly of this AOD, and as well as the decomposition of the intrinsic modes which is carried out by the empirical mode decomposition analysis. And this panel shows the individual of decomposition of empirical mode, which you have seen in the 4. Then this corresponding this decomposition, this periodicity will be calculated using periodogram analysis. So which will give that what kind of oscillation dominated. So what we observed for a typical example of only one I have shown in the AOD pattern. So what we observed, we have seen that in semi-annual, annual, QBO and ENSO. Yes, sir.
2 more minutes.
Yes, sir. Yes, I will continue. So these are the patterns we have seen from this, and these corresponding index have properly taken and removed from the multilinear regression trend analysis, and this shows the complete structure of the trend analysis of long-term trend. So, so what we seen from the aerosol, in the aerosol patterns we have in aerosols we have seen that aerosol was continuously increasing in the AOD, and there is a when the increasing in what kind of because it has a coarse and fine mode particle, this will clear in the angstrom exponent. The angstrom exponent says that though it is aerosol increasing, the fine mode rather than the natural variability, the fine mode fraction get increases, and the bound layer extension shows decrease in the trend, but however it is not significant. And whereas similarly there is a change in the vertical pattern, the free troposphere extension have increased, and the cloud effective radius decreases and cloud fraction is increased. This shows the semi-indirect effect of aerosols very strong. However, the cloud top height, cloud fraction, cloud optical depth, liquid water path, and these are they either nor decreasing or nor increasing or decreasing trend we have seen. And the bound layer temperature also we have seen a slight decrement in the and free troposphere we have seen the increment in the temperature with a significant level. And as I have, and however the rainfall is not showing either increasing or decreasing trend. So with this I will conclude my summaries goes on. So the study site is strongly influenced by the aerosol semi-indirect effect, and positive values, and we have seen the positive values for respectively 40 to 60% between the anti-TOMI and TOMI effect. The increase in the AOD results in a decreasing and the BL temperature, and increasing the FT means free tropospheric temperature indicates a high aerosol loading in free troposphere causes a surface dimming, and then we have seen the negative relationship between aerosol and with respect to the rainfall, resulting the fine mode particles delay or decline the precipitation process. When we see the parameter of multilinear regression trend, the AOD and the angstrom exponent shows the statistically significant increasing trend, and cloud effective radius and cloud fraction statistically decreasing and increasing with respect to the level of significance. And as well as and free troposphere also we have seen the level of statistically significant increasing in the trend per decade, 0.5 Kelvin per decade, and whether other parameters are negligible change in either decreasing and increasing over the period of 2001 to 2018. So this, thank you for giving me the opportunity. I will take the questions. Thank you very much.
Thanks a lot, Arvind. Well, firstly for accepting our invitation and rescheduling your talk. It was a very informative, elaborative, where you have made use of long-term data for Chennai. So let me see if any questions are there from the audience in the chat box. Right now, I don't see any new questions. So overall, anyway, I really congratulate you for very good work. So maybe thank you for your presentation. We will go ahead and with the next presentation. Arvind, well, can you please stop sharing your
Yes,
screen?
sir. Yes, sir. I will do it.
So that's the next presentation. We will try again with Aditya Jayaswal.
Hello, sir. Am I audible?
You are audible. Can you please share your screen?
Yes, sir. I have shared.
Samresh is also there. Actually, Samresh made a presentation maybe from a different terminal. You are trying to share, Aditya? Are you trying to share your screen now?
Yes, sir.
Still looks to be some technical problem. Maybe if some of your colleagues there can help, or maybe LOC. LOC is telling that we have to share the entire
Can you see the screen?
We do not see right now.
Now can you see?
We still do not see. If I see, I will definitely confirm.
It is present.
Aditya, can you please elaborate on what kind of errors you are getting or from to LOC so that LOC member can try to help you?
Okay, sir, when I'm clicking on the screen, here I'm getting two options, and then I'm going to desktop, but after that it is showing presenting, and then that option also goes away. I don't know why.
LOC, can you please comment on?
Aditya sir, have you tried closing the Teams app and then rejoining?
Which app, ma'am? Sorry, can you repeat once again?
The MS Teams app.
Oh, ma'am, I am joining directly from the browser.
Okay, even in are you signed in through your browser or you don't need to sign in?
I'm signed in.
Okay. Just give us a minute, we'll be back.
Or otherwise, what we will do is, as we are approaching towards the end of the session, we will try to take up Aditya, your presentations in the session B. We will have a half an hour break. So during that time, maybe you can once again check up with LOC and you can try to see if your screen is presentable.
Okay, sir. Okay, sir.
In the terminal, you can also contact your other colleague, Samresh. So we will take up your presentation in session B, which will be starting at 16:30 hours. Okay, Aditya.
Okay, sir. Thank you.
So thank you once again, all the audience, for very attentively attending this session. We had a very good presentations, total 7 in numbers. Dr. Samresh initially started with the detailed insights on the wind profiler at Aries, which is operational at 206.5 megahertz. It was followed with Som Sharma, who introduced a new term, epidemiology, which actually tells how the ABL processes possibly are linked with COVID-19 spread. We had a very detailed presentation by Siddharth on the stratospheric water vapor in association with the Indian summer monsoon. And then Maria made a presentation on the supersaturation phase of water vapor. Aditya, you may mute. And then Priya made a presentation on the Moody's data and presented some very interesting observations on the cirrus for 6 different regions of the Indian region. Anjana made a presentation on the Hadley cell expansion using the arrow technique. And finally, Arvind Well presented a long-term aerosols over the Chennai. In short, I can say, starting from the boundary layer to the middle atmosphere, we touched almost all. So it was a feast starting from the soup to the dessert, all in one. I would like to thank all the presenters for keeping the time. Also, I would like to thank our LOC members who helped all the speakers to go ahead with the smooth presentation. And also, it was my pleasure to chair this session. I will hand over the session to Dr. Kishore Kumar for further announcements.
First of all, I thank Dr. Balasubramaniam to conducting this session very lively. Now I think Aditya is having some technical difficulty. So as he suggested, he can try in the session B. So now we'll take a tea break and we'll reassemble at 16:30. Is it okay with LOC?
Yes, that is fine. Just a notification that there are some questions from YouTube if you would like to take them up. It's there on the chat box.
Only one. Arundville, are you online? Hello, Mr. Aravindavel? It's not there. Yes, sir, I am. There is a question from YouTube, especially. The question is like, what is the significance of negative and positive ACI values? What is the acceptable range of ACI using EMD analysis? Did you remove the volcanic contribution of AOD?
Am I audible, sir?
Yeah, we're audible. Yeah.
Thank you very much, sir, for a nice, very nice questions. Question. So, as first, there is a two-part. First part is the answer question that what is the significance of a negative and positive aerosol cloud interaction values. So, what we in generally what we observe that when the standard deviation we used to take from the overall every respective of this is with respect with the liquid water path at a constant water path. So when the difference in the at every water path is taken, the mean value should be as a means the standard deviation should not above than the mean value, which we generally considered as the ACA is a significance level, as I have seen in the some Kant et al. 2020 it is reported. And next part of the question it is like acceptable range of the this is it's answered acceptable range. That's what I have seen from the literature says that. So when the mean value should be higher than the standard deviation should not higher than the mean value. And second part is that then EMD analysis, did you remove the volcanic contribution there? Yes, sir, it is a good question that volcanic, but I have not gone for a volcanic trend analysis, but however, I have removed the solar cycle and this kind of QBO, ENSO and other seasonality oscillation. Up to that oscillation I have done, I have not done for the volcanic eruption. So maybe further I can add from your point, I can add for the again extending the studies and will give the more authenticated results.
Thank you, Arundel, for your clarifications.
Thank you very much, sir, for giving the opportunity, and thank you very much for NSSS LOC team also.
Yeah. Thank you. Now we will have a tea break. Reassemble at 16:30.
Thank you all. With this, we come to the end of session APS2 for day 4. We thank the speakers for the interesting talks and the chairs for moderating this session. We will be back for session B at 4:30 p.m. Just a reminder that for the closing ceremony of the 21st National Space Science Symposium, please use the link that is shared with you on the website and also via email. Thank you. We will be back.